Hi. So today we will learn capacitors. We already know some devices like battery, cell, all these stores chemical energy in that. And we can run so many devices using these chemical energies, like we can light a bulb, we can run a fan, we can even watch TV using batteries. So battery is a device that can be used in so many ways, as it is storing chemical energy. In the similar way, we have one more device called capacitor, which stores electrical energy. By storing charges. Now, the capacitors can be any conductor. Conducting plate or plates of any shapes of and as per their shapes, as per their size, their charge holding capacity is changed. So simply we should start from a combination of two plates, and these plates can retain charge of different magnitude. Suppose this plate is containing a charge Q1, this plate is containing charge Q2, and it is having potential V1 and it is having potential V2. Therefore PD, potential difference, can be written as V2 minus V1. And these plates you can see have different charges. But for a simple description of capacitor, what we are going to do here, that we connect two adjoining plates by the terminals of a battery. So what will happen? These are the terminals of a battery, so they will provide equal charges on these plates, but these charges are of opposite nature. So if one plate is having plus Q charge, so other will be having minus Q charge. And this you can consider as a capacitor, as it is holding charges. Capacitor means, the literal meaning, if you go, then you will see that it has certain capacity to hold something, and actually it is holding charges. Okay. So how it helps? So let me explain. What is a capacitor? From here you can define also. A capacitor is a combination of two plates of equal and opposite charge. Okay, let me. Which has capacity to hold charges. Let me wrap this like this. So it holds charge, okay, and it hold electrical energy stored in it. Now, what is the charge of this capacitor? Though you can find that net charge is equal to plus Q minus Q is equal to 0. But the charge on a capacitor is taken as the charge on a positive plate. So the charge on a capacitor is equal to charge on positive plate. And this is equal to plus Q. Now, you know that if you have a plus Q charge, so it will be creating certain potential V. And you will find that the potential will be equal to KQ upon R. So what happens if you increase the charge twice? If you take 2Q charge, then potential becomes K2Q by R. So when charge is double, potential also is double. When charge is thrice, potential also is thrice. So you find that the potential that is developed is actually proportional to the charge on positive plate. And this constant of proportionality is called capacitance. The constant is called capacitance, and therefore from here we can find that capacitance is equal to Q coulomb upon V volt. So what is its SI unit? SI unit of capacitance you can find that in numerator you have charge Q, so unit will be coulomb, upon in denominator you have potential, so you will be having volt. So its SI unit is coulomb per volt, and the same is also written as farad. SI unit of capacitance is farad is a very large unit. I will be discussing later. so let me do. Okay. So this capacitor is of two kinds, a constant capacitor and has symbol. For constant capacitor you can take two parallel lines like what you take in batteries, two parallel lines but of different lengths. But here the lengths are same. This is the symbol for a capacitor. Okay, now variable capacitor. For that you will have the same symbol, but you use an arrow which is cutting the two parallel lines. So these two kind of capacitors do you have. Now we know that capacitance is equal to Q upon V. So how we can use this device practically? So capacitance will be more when you have charge more with less potential. So practically we try to find a device, a system that we can call capacitor, which is holding more charge at less potential. It is very essential because we know that your potential difference is somehow related to electric field. So if electric field is increased, so your potential also is increased. But for insulators, for dielectrics, like air, electric field has certain limit. After that, the dielectric air will be converted into conductor. It will turn conductor. So that maximum limit of electric field max, so that air remains dielectric and it does not turn into a conductor, that maximum electrical field limit is equal to 3 into 10 upon 6 volt per meter. So if you increase electric field in the vicinity of any conductor more than this value, then the air surrounding that conductor will start conducting the charges on the conductor. So suppose you increase electric field to this value, even more than that, then air near the conductor will become a conductor, and the charge which is held by this capacitor plate will start conducting to other plate, and you can see that the charge on the capacitor reduces, and as charge reduces, capacity of capacitor also reduces. So we will try to not increase electric field to this value, and so we will try to keep the value of electric field and thus potential, and we will try to increase the value of charge, and such a capacitor can be used practically for so many works. When you hold the value of potential and increase the charge, then capacitance will be more. Now its usage of a capacitor. So in so many devices, in almost all electrical circuits, we use capacitors. In our house we have fans. In fans we use condenser. These condensers are actually capacitor. Next use, it is used as filter circuit. Used in a rectifier. Rectifier is a device that converts AC into DC. Now when AC is converted into DC, means unidirectional current, then also its value varies. So when you use a capacitor, it filters the variations and it gives smooth DC current. So in filter circuit, in tank circuit, in tuning circuit, tuning circuit, we have radios and we tune for having different channels, and we move the knob. We actually, while moving, we change the capacitance of a capacitor. So capacitors are also used in tuning circuit in your radios. You have one more circuit that is called tank circuit. We will be explaining it further. So these are its uses. Now we will learn, today we will learn how to find the capacitance of a parallel plate capacitor. And yes, one more thing. So you find that when you increase Q, V also increases by same amount. Suppose Q is increased by 2 times, V also increased by 2 times, and finally you have the same value of capacitance. So capacitance does not depend on the value of charge and on the value of potential. Okay, now we will find capacitance of parallel plate capacitor. So we have parallel plates, and for finding capacity, here you can see here, for finding capacity we need to have charge and we need to have potential. So we will assume certain charge on one plate. Suppose the charge let us suppose the charge is on the surface of the conducting plates of capacitor. V plus Q and minus Q. Okay, so the electric field inside the two plates, for positive plate it will be directed outwardly, and for negative plate you will find the direction of electric field will be perpendicular and towards the plate. So the two directions are along the same directions. The two electric field due to positive charge, let it be E1, and electric field due to negative charge, in this figure let it be E2. You can see both are directed along the same direction. So for net electric field E net, you will be adding the two fields E1 plus E2 due to the surfaces of the charge plate. Having charge density sigma, okay, so you know that electric field is equal to sigma upon 2 epsilon naught. You have already obtained this. So E1 will be sigma upon 2 epsilon naught. E2 will also be, as the charge is same, charge density is same. So it will be also, the magnitude of it will be also equal to sigma upon 2 epsilon naught. So therefore E net and magnitude of it is equal to 2 sigma upon, okay, let me add the 2, is equal to E1 plus E2, and this is equal to 2 sigma upon 2 epsilon naught, and finally you find the electric field. Now potential between the fields, suppose let the distance between the two plates be D. Therefore, potential difference V is equal to EdR is equal to, E into D only, and this is equal to sigma D upon epsilon naught. So this is how you obtain potential. And charge, what is charge? We have assumed the charge is Q, but we know that charge density, since charge density sigma is equal to charge per unit area, therefore charge can be written in terms of charge density. So charge is equal to sigma into A. So we have two things. We obtain potential and we have charge also. Now we can find capacitance. Therefore, capacitance, which is equal to, since capacitance which is equal to Q upon V, therefore capacitance is equal to sigma A upon, and for V let me put the value of potential from equation 1, sigma D upon epsilon. So therefore you find that capacitance comes equal to epsilon naught A upon D. From here you can find that capacitance depends on area of the plate, distance in between the plate, and also this permittivity, means nature of the material. So let me conclude by writing these things. Capacitance of parallel plate capacitor of it. Number 1, does not depend on charge. Does not on charge. B, it does not depend on potential event. Here you can find that there is not mention of potential in this equation, so it does not depend on potential event. And it depends on dimensions, means length, breadth, size. Okay. And it depends on separation. Separation D. And it also depends on nature of material kept inside. Nature of material. Dielectric, obviously. So when you have air in between, which has dielectric constant different than other materials, then it will have different capacitance. Suppose you have take some another dielectric material like a plastic, like a rubber, then it will conduct differently, then its capacity will be different. So there is a term called dielectric strength. it varies from material to material. If you take air, its strength will be to hold the electric field. It can hold an electric field which is equal to 3 into 10 to power 6 volt per meter. So if you take some different dielectric, it will hold different electric field. So in this way we find that, so what dielectric material you are taking in between the two plates on which your capacitance of the parallel plate capacitor depend. So what is dielectric strength? Dielectric strength is the ability dielectric strength is the capacity to hold the insulating nature of a substance for a given electric field So here I conclude